Hello everybody, this is your video on our new topic called the constant of proportionality. Now this is a number that you may already know, as it is also known as the unit rate. The unit rate is the constant of proportionality, but what's special about the constant of proportionality is that it only occurs when two things are proportional, hence the name constant of proportionality. If the relationship is not proportional, they cannot have a constant of proportionality. Now the constant of proportionality here, the constant of proportionality, or K, we let the letter K represent our constant of proportionality. C was already taken, and you'll see that when we get into our circles unit. So it's K. It is a ratio comparing two quantities in a proportional relationship. See, there it pops up again, proportional relationship. If you're not proportional, you cannot have a constant of proportionality. This is very similar to our scale factors. If the relationship is not proportional, you don't have a scale factor. So remember it that way. This here, over yonder, is the formula for the constant of proportionality. Constant of proportionality can be found by doing y divided by x. Doesn't this look awfully familiar? Scale factor equals new over old. Remember how we talked about tables representing things? Typically it goes old then new, because you do something to the old to get to the new, like 1 times 2 is 2. It looks very similar and works in a very similar fashion. Okay, let's slide on down. First, we're going to focus on constant of proportionality in graphs. Now, it's important to be able to identify the constant of proportionality in a graph, but it's also important to identify whether or not it will even have one. So take a minute and take your knowledge from yesterday and try to identify which examples in example 1, 2, and 3 are proportional. All right, first and foremost, example 1 is proportional because it is a straight line and passes through 0, 0. Example 2 is proportional for the same reason. And example 3 is not proportional because it doesn't pass through 0, 0. So if it's not proportional, can it have a constant of proportionality? No, it cannot. So no constant of proportionality for this guy. None whatsoever. Not possible. All right. So let's come back to example 1, example 2. Now over here, we just highlighted those steps. Is it a straight line? Does it pass through 0, 0? If it does, then you can find the constant of proportionality, or COP. If no, then you can't find one. It's not possible. Now you're saying to yourself, well, Ms. Carbone, how in the heck can we find the constant of proportionality from a graph? Well, we know from what we just defined the constant of proportionality is y over x. So there's a couple of ways how we can do this. First, we can use constant of proportionality equals y over x, and we can pick a random point on the line. Just make sure it's a good point. When I say it's a good point, that means you can tell exactly what the coordinates are. This would not be a good point because it would be like 3.2, 6.5, no way to tell what that actually is. A good point would be something like this one. You can tell exactly that this would be the point 2, 4. We know this because 2 is the x value, and 4 is the y value at this point. Now we can just plug it into our equation for the constant of proportionality. Y over x. 4 over 2, that simplifies to 2. So our constant of proportionality, or K, is equal to 2. And that is our final answer. Another way you could have done it is thought about it in a table. X, Y. And you could have looked and said, okay, where's the good points? Here's 1. So when x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. And when x is 4, y is 8. Here you can clearly see that your multiplier is what? Times 2, times 2, times 2. Do you think that this is a coincidence? That your constant of proportionality is the same as your multiplier? It is not. They are one and the same, and they function that way. That's why we do the y over x, because it tells us what we multiplied by. I hope this is sounding familiar, because it's the same thing we do when we found scale factor, right? All right, take a minute, pause the video, see if you can figure out example 2. Work with a partner, work by yourself. Try to figure out what the constant of proportionality is for example 2. All right, let's get to work. Example 2, I'm going to stick to the equation way because I think it's the easiest way. So we have our equation of k equals y over x. You're going to want to memorize that, by the way. Let's pick a good point. All right, I'm going to say that point. Is that a good point? I hope you said no, because it is not. A good point would be, I don't know, let's pick this one here. This is the point 3, 9, because the x is 3 and the y is 9. Notice how I'm labeling them each time, and that's on purpose so that I don't accidentally do the wrong math here. So let's go ahead and we have 9 over 3, and that simplifies to 3. So our constant of proportionality, also known as k, is 3. Final answer. Now you can check this by saying, okay, 2 times 3 is 6. Does that hit at 6? It sure does. 1 times 3 is 3. Does it hit at 3? Sure does. So that's one way you can check your work as well. So that's the constant of proportionality in graphs, which is, also known as the unit rate, and is found in a very similar way to how we found the scale factor. Let's come on down to tables now. Finding the constant of proportionality in tables, there's a good set of steps to identify. The steps are right here, and I will highlight them in hot pink. Right here, we have step 1, 2, 3, and 4. Step 1 talks about identifying the x and the y as the independent and dependent variable. Now, if you haven't talked about this in science yet, you're about to, so hopefully this can help you. The thing to remember, and this is most important, y depends on x. That's like saying the amount of money you earn per hour, so like for the workday, depends upon how many hours you work. If you earn $10 an hour and you work 6 hours, you'll earn $60. Now, the independent variable is most typically time-based. Usually has something to do with time. Years passing, hours passing, something like that. And our dependent variable is usually an object. So like pants, shirts, pens, something like that. Now this part here where it says make ratios, y over x, we know better. We know that that is saying find k, because we're doing a constant of proportionality. The reason why we're finding k or checking for proportionality, is because remember, if it's not proportional, there is no constant of proportionality. So here, if yes, then we're good to go. If no, then you know there is no constant of proportionality. Last but not least, find the constant of proportionality. But really, you're doing that in this step where you're checking. All right, Example number 1, like we did in class yesterday, extend your table. Here we're going to check our ratios. We're used to doing new over old, which is the same as y over x, which is the same as the dependent variable over the independent variable. In this case, it would be 3 over 2. The next set would be 6 over 4, which simplifies to 3 over 2. And the next set would be 12 over 8, which simplifies to 3 over 2. Notice how all your ratios are the same once simplified. Make sure you simplify them. So this means a couple of things. This means that 1, it's proportional. And 2, the constant of proportionality, which we get from doing y over x, which is what we checked here, is simply that simplified ratio of 3 over 2. So now we know our full answer of it being proportional, and the constant of proportionality is 3 over 2, aka that simplified ratio, not radio. All right, let's take a look at example 2. Example 2 says miles swam to hours. Ask yourself if you're not too sure. Do the number of miles swam depend on how many hours you swam for? Or does how many hours you swam depend upon the miles you swam? Your independent variable, or the x, we'll call this the IV. Independent variable is the hours. The y, or the dependent variable, dv, is the miles swam. Now, to keep ourselves straight so we don't mess up, let's label it in our table. The hours swam is the x, and the miles swam is the y. See how they kind of reverse that on you there? That's why it's important to identify which one is the independent variable and which one is the dependent variable. That way you don't get tricked. So now let's check for proportionality, or check that ratio of new over old, or y over x. We get 6 over 2, which simplifies to 3. Next one, we get 24 over 8, which simplifies to 3. Our last one, we get, second to last one, we get 48 over 16, which simplifies to 3. Last but not least, 54 over 18, which simplifies to 3. Do you see how all of your ratios simplified to be the same number 3? That means that yes, it's proportional. It's proportional. And k equals 3. So not only do we know it's proportional, but we know the constant of proportionality, also known as k, is 3. If you're feeling confident, go ahead and give number 3 a shot. If you're not, stay here with me. Oh, that's right, I forgot. We changed this title to just total cost. So you're going to want to ask yourself, does the total cost depend upon how many candy bars purchased, or do the candy bars purchased depend upon the total cost? Hopefully you said, well, the total cost depends upon how many candy bars I buy. So the dependent variable, or y, dv, is going to be how many candy bars we purchased, right? How many candy bars purchased. Now the independent variable, or the one that that doesn't depend upon the other, would be our total cost. And again, that's because the total cost, I'm gonna have to fix that again. Okay, so now let's talk about which one is the independent variable and which one is the dependent variable. The cost depends upon how many candy bars purchased, or how many candy bars purchased depend upon the cost. Which one sounds right? Most typically, you buy however many candy bars you want, and it costs however much those particular bars total to. So that means that the cost depends upon the candy bars purchased, the number of candy bars. That makes the number of candy bars our independent variable. So I'm going to put number of candy bars. Because it doesn't matter. You can choose to buy however many you want. Let's just pretend you have unlimited money. That would make the dependent variable, or DV, the total cost. And don't worry if that tricks you up a little bit. You'll get there. It'll become more second nature as you go. All right, now as per our steps, we're going to check for proportionality. So we're going to extend our table and check the ratio of y over x. Always good to fill in, so you know the number of candy bars is your x and the total cost is your y. All right, let's check this one, y over x. 5.75 over 3. Because this is going to be hard to simplify, we will simply divide it. 5.75 divided by 3 is 1.916 repeating. Let's check the rest, see if they get to be the same decimal or if they end up being different. For our second one, we have 8.75 divided by 5, which gives us 1.75. Need I continue? Hopefully you said no, because these are not the same, which means it's not proportional, and therefore we do not have a constant of proportionality. All right, I hope that this helps you understand it a little bit further. More so understanding our new terminology of constant of proportionality and how it works very similarly to our scale factor previously. Just to wrap it up, remember the constant of proportionality is just your unit rate, and it can only be found in proportional relationships. Graphically, that means it can only be found in things that are a straight line and cross through zero. And in a table, that means it can only occur when you have the same ratio. And fun fact, it is that ratio. Same thing with the graphs, because it is the ratio of x to y. Alrighty. Once you're finished with this, good luck and find out what your next activity is. Thanks, guys.